Okay. Oops, I knew I didn't. Okay, I'm gonna. Well, I think this is about as full screen as we can get. So you'll just have to. I don't know why this thing is. Okay, there we go. So you just have to slide down here. Gotcha. Okay, and I need to make sure. You talk into here. That would be great. Yeah. Let me move this. For you. Okay.
Okay, I'm Bill Winkler from the Census Bureau. I'd like to thank Joe for inviting me to be the discussant. Becca, which you wouldn't know, but experts know, is one of the best young statisticians working on record linkage, and she's done some really fundamental work. There's some other work by a few other statisticians, but it's all within the last maybe 6 years. I'm going to give a little bit additional background that'll fit in with the topic of this session overall. So earlier when Chris Chapman gave a roundup and stuff, he mentioned some applications that people
mute on.
Sort of repeating here. When I first was working in record linkage, and I was actually doing work with Fritz Schuren at times, we worked in economic agencies, and we wanted to bring data together that could be analyzed. And the econometricians wanted to model the economy. You've also seen the situation where people are in the health sciences, and they want to bring together data associated with individuals. Well, those problems are very much open, and even though the health groups for more than 30 years have tried to do the linkages, they're still having drastic problems. So they talk about something called the Master Patient Index, but they haven't been able to create that. So our situation looks a little bit like this. We have file A that has some data that we want to analyze in conjunction with file B. Maybe we have name, address, date of birth data that we want to use for linkages. But there's a lot of typographical error. Addresses can be outdated and things. And so we want to try to do the linkages and then the analyses. So the things we have to worry about related to our analyses, we have to clean up the two original files, or it could be even more than that. For missing data and edit errors, like a child under 16 can't be married, we have to use modeling edit imputation. Then we use our record linkage, data linkage, to get rid of the duplicates in the individual files. When we create our merged file, we use our data linkage again. And then an issue is going to be that we're going to have a lot of linkage error. Often we can't estimate that. Becca gave some ways that we could do it. But adjusting the statistical analyses for linkage error is still an open problem. In the last 52 years, there's been about 19 papers, and I think the problem is between 5 and 20% solved. Now, you're not touching on those things, but that's the ultimate goal of the linkages, is bring data together that you can analyze. And then, of course, with our administrative lists, we often have to use hundreds of millions of records or even billions of records. For instance, the large Social Security Administration and IRS files are about 1 billion records each. And most of our software isn't fast enough. So there's cautions about if we have errors in the files and we haven't necessarily cleaned it up. If we had 5% error in the files A and B, 5% matching error, we're going to have about 15% error in the combined files. So the issue would be if there's 15% error, are there any analyses that are possible? If we had efficient ways of cleaning up the data, the error is reduced to 5%, then what analyses are possible? Nobody's looked at those yet, except in very sort of ad hoc. And then mostly, and this is even true in the statistical agencies where we have much better skills than most places, we can't say how much error there is in our files, what the quality is. So here's an example related to the Flegge-Sunter model of record linkage. On the x-axis, I have the natural log of the main likelihood ratio that they use in their model. The y-axis is just the frequency of the scores. And the blue represents true matches. The red represents false matches. And we're going to have in-between regions where we can't make a decision. And I'm going to come back to this. And part of it is that outside of maybe the Census Bureau and a couple other places, the people haven't had very, very high-quality test decks that allow you to really effectively evaluate how well you're doing. If you have pretty simple test decks and you think you're doing really well, and as soon as you get a much more difficult test deck, you're not going to be doing as well. And most of our administrative lists are going to be at least more difficult to use than some of our census files. Now, Becca pointed out the transitivity issue, and that's if two records can be brought together. Does that mean that 1 with 2 and 2 with 3, does that yield that 1 can be combined with 3? Generally, that hasn't been true. So the Flegge-Sunter model definitely doesn't cover that. When we looked at ag census data a number of years ago, it was never true there. It was something that Cynthia Clark had brought us in to do some record linkage for her and her colleagues. A number of the computer scientists have looked at it, and other computer scientists have gone in and examined the transitivity and discovered that it often doesn't hold. However, in a number of situations, we can get by. So issues that we have is that with record linkage, we generally don't have training data. So the method in what Becca calls BLINK is unsupervised learning method. You don't have training data. But I'm going to say some things more about that, and it relates to our 1990 census production software. We needed to find optimal parameters according to the Flegge-Sunter model, but we had to do it in 500 regions, not in one, like with the pair of files. So we had 500 pairs of files. The matching needed to be completed in 3 to 6 weeks. So with the census, you have about 300 million records. That's a lot of matching. So we had to have software that was fast enough for that. We figured out how to do optimal parameters. That's without any training data. And we did the matching, and the error rate ended up being about 2%, or about 0.2% for the false match rate. And that was within the bounds that were required for the accuracy of the matching. So we got optimal parameters. We did the matching in 6 weeks. I later did some evaluations and some comparisons. One of the methods was called active learning or iterative refinement, which was used widely at like Statistics Canada and some other places. They would do a clerical review, get truth, reevaluate their parameters, and keep reevaluating more and more pairs until the parameters converged. Well, if we had used that procedure, it might have taken us 3 weeks or more in each of the 500 regions to get our parameters. what I was later able to show that we were doing a best naive Bayes approximation of a general interaction model in log linear models. And that gave us actually better parameter estimates because we were using a more powerful model than what some of the statistical agencies and other groups at the time had been using. The methods have been rediscovered by Kim Larson in some of the computer science literature. He used general additive models, but those are much slower to compute. Now, we've been using the software, that set of software, since the 1990 census. The interesting thing, and this says about what our test deck was like, I showed you those curves where there was an in-between region. In the 1990 census, the in-between region consisted almost entirely of pairs where the first name and age were missing. We called those blanks. So we had to follow up somehow. When we did the follow-up, and we had the clerical resources to do that, only 1 out of 40 of those blanks in the suburban regions was actually a true match. In urban regions, because the typographical error rates are higher, only 1 out of 10 of those were. So by doing the follow-up, that was 2% of the matches that we had to find. And that tells you about a little bit about the quality of our test decks. We had people who could go and do that, and we had adjudication and everything. There was an additional small proportion, 1 to 2%, that had to be estimated by a method of Tom Bellin. He's a former student of Don Rubin's. And then we had another 0.5% where the pairs had no 3 grams in common. 3 grams are 3 characters. You go through an entire record. Any 3 that you take can't be found in the thing that you're trying to match to. So those were found during the field follow-up. So we had very good field people. But the issues related to these test decks are that you need the high quality to say, well, really, we're doing this well. In our case, we had to have block level counts. So I'm not going to go into detail about Steorts methods, but they are some of the best methods around. We'll be investigating them, and we're going to have to get the type of resources that are needed to try them out in some of the test decks we have at the Census Bureau. In particular, the research that's going to be done, you need a lot better test decks. You're going to need people that understand the methods and where the methods break down when there's errors in the data. And, okay, that's it for my discussion.
Thank you, Bill. So we have, because of our late start, about 6 minutes budgeted for discussion, but we can go a bit over because we have a break after that, and we have 75 minutes scheduled for lunch. That was intentional so that in case we went a little bit over, we would still have plenty of time. I'll start with 2 quick questions. One is that I think I noticed that in the example of the Syrian conflict that Rebecca was talking about, there were multiple lists that were then stacked on top of each other and then deduplicated, which is an attempt to identify errors of duplication, records that appear multiple times, or individuals that appear multiple times in the list. But is there any serious methodology that you're using for the other type of error, which is individuals who are out there who are not covered by any of the lists? And so I'm curious about that, and if there are any evaluation metrics that deal with that. And the other general question I have, either for Rebecca or for Bill, who talked about this, what hope do we have for evaluating quality in a situation where there really is no truth spec or no hand-matched subsample for evaluation? So those are my quick questions.
Mute off.
I could make some comments if I could stand up there. Why don't we pass this off?
Joe, can you hear me?
Yeah, I just couldn't.
Let Becca do first.
Okay, Becca, you're on.
Great. So so they're both really great questions. So I'll tackle the first one, Joe. So with respect to the Syrian data set, we've been approaching it two different. So with respect to the Syrian data set, when I showed it on my slides, we actually approach it as three. We actually have 4 different data sets for the Syrian data set, and the way we approach it is there are records across and within. So we don't actually cram it into one data set. And so we're actually able to propagate the record linkage uncertainty exactly. There are other methods. So I think your question is, well, suppose I came up with a method where I did only use it, I only tackled it using deduplication and I crammed those 4 data sets together. Well, then the best hope is you can derive these bounds for the record linkage uncertainty, but it doesn't really, it doesn't allow you to propagate the uncertainty into the estimation process. Or typically what you want to do is you'd like to do the record linkage, and then you'd like to do some sort of capture recapture because you actually want the population size estimation. And so if you only have a bound, then it may or may not give you some sort of indication of how accurate you are. So that would be my answer to your first question. And can you repeat your second question?
The second question was, what hope do we have for doing serious evaluation in a situation where we don't have a hand-matched subsample?
Sure. So this would be, so this is some work that I'm doing, that's ongoing work with my postdoc, Andy Kaplan, and so this is a great question. So this is something that we're looking at. So typically what we do is we'll evaluate the methodology, we'll evaluate the proposed methodology on lots of different data sets to try and get an understanding of how it works on maybe 5 or 6 different data sets where you have ground truth data. And then, for example, we turn to the Syrian data set where we don't have ground truth data. So then what we do is we take lots of different samples from that, and you can do something like bootstrap samples, things like that, and to try and assess, well, how accurate, if I take, for example, 1,000 different samples, and if I look at my estimate, then what is my standard error? The evaluation concept there in terms of false negative rates and false positive rates just goes out the door. So something there needs to be more carefully thought about, and so I don't have an answer there. But so maybe that's kind of a partial answer, but that's something we're looking into and investigating, because there are a lot of data sets where you only have where you don't have any partial information. Maybe as another follow-up, we have there's this recent paper that's in minor revision at the Applied Annals, where suppose you have even just a minor amount of hand-matched data, which seems to be feasible in practice. Then then you can use this method that we proposed. So this is a paper with Betty Chen and Anshamali Shirastava. And it's on arXiv, it's on my webpage. And what it allows you to do is it allows you to build up some sort of a truth stack. So you could take either one of those approaches, and it would be interesting to compare those in practice to see how they differ.
I have two examples with our 1992 ag census matching. The ag census people asked, well, what was the false match rate? And based on experience, I could estimate it to be about 2%. They have to do their field follow-up to evaluate all their crop estimates and livestock estimates and everything, and during that, they could also evaluate the duplication. And according to their validation, it came to 1.8%. So with a little bit of experience, skilled people can give plausible estimates. With our business register matching, what they did, they asked, well, what's the false match rate that we're getting? And that's quite difficult. And I gave them between 2 and 5%. And our economic directorate had actually withheld what were called the EIN, the employer identification numbers, from 20% of the records. So they were able to very quickly verify that the accuracy was what we said it was. And the business matching is much more difficult, as some of you know.
I have a follow-up question for that, Bill, though. But so, originally you don't have a truth stack, but it seems like when they do the follow-up, then you have a truth stack. So then you're calculating the false match rate using a truth stack.
Correct.
Is that correct?
Correct. So for the census, it was about 500 regions, but during our pre-testing, we had about 6 regions that we did it over about 6 years.
Okay.
And so we had things that were a little bit like what we had to match, but when you're in a big production situation, like some of your name and address standardization software can fail. In the ag census, the address standardization completely failed. We had to bring it back off some of the faxes that we had and put it on a Linux workstation in my office and do the entire matching there.
Yeah, so just to follow up, like with your question, Joe, I think something that would be very feasible to do is if you suppose you only have less than 1% of a truth stack, that you could actually build one up using this paper that I read. You can do it in linear time.
Okay. We have a few more minutes for questions. Is there any interest from the floor? Frauke.
Thank you, Becca and Silver, for the specific lots of references, lots of follow-up. So one question you mentioned sort of additional challenges from all these errors in the data, and Becca showed some of the examples. I was just wondering, is there sort of a form of pre-processing that you found particularly useful that is more than sort of what we know from linguistics, typical, misspelling and typing, but some pre-processing on a sort of known or likely errors through the process of how the data was entered. So I'm thinking of the examples in the German context with the employment agencies when, some agency officers enter the data and, they typically leave out the middle name. So I don't know, just systematic processes that happen, and did you see an example where that has been?
We don't deal with it during the pre-processing in general, although with experience you could look at some things, but we actually deal with it during the matching. But you're still going to have a lot of errors in the data. So I'll give you an extreme instance with one of the administrative lists that we use. We wanted to do school board, and in a given area area had permission to use it and match it against the census. The schools are the school board data is broken out by schools and classrooms within schools. As we were matching it, we noticed a lot of errors. And I went through the data, and for half the classrooms, every first name, every last name, and every date of birth has been miskeyed. And with the other half, there was no error. And unless you have a way of determining that, you can't say, well, somebody's miskeyed this. And you figure, look at a date of birth with our typical representation. A lot of those can be screwy, or they might have copied it off the wrong line of a form, which happens with voter registration databases and other things. Chris?
Okay, very good. One of the primary purposes of kind of organizing these workshops is to help the agencies figure out what it is that we need to report out to the public on the metrics that we use to evaluate these techniques. So the discussions today were really helpful in terms of understanding the techniques themselves, but are there sort of standard metrics that recommend to the public about either how the matching works, with the match rate high, and how to evaluate the techniques that we use to actually do the match?
The two standard metrics, which are the same in computer science and in the health literature, would be precision and recall. And then for record linkage, also the reduction ratios. But those are the main three. And Peter Kristen's book has quite a bunch of details and examples related to that. And he had some precursor papers that also covered it. We've covered it in all our things, too. But it's very difficult to estimate even false match rates. So there's a paper by Tom Bellin and Rubin in JASA 1995, and then another one by Mark Larson and Don Rubin in JASA in 2001, where they give some methods for that. But they aren't very easy to apply.
Okay, well, we received a message from Becca saying that she can't hear anymore. And maybe because of that, this is a good time to stop. We're getting close to 10:25. So let's take a break of about 10 minutes, and we'll start up again at 10:35.
Mute on.
Okay, I think I've got everybody muted except for the conference phone. Let me know if you can hear me. Just send something on the chat, somebody. Thank you.
He is.
what I'm saying is they don't have any service for it. That one is easier than the it's easier to check. There an example where somebody that has perfect is one of the measuring the color of the data that the measurement represents. But that one is not what we're making it easier. You can use them before matching. You can add some variable. For example, generate something in the both data files and after matching. Oh, okay. The one that matches